to the first problem. On the screen you can see the wall of a steel tank that contains hot water at a temperature of 95 degrees Celsius. Ambient air temperature is 15 degrees Celsius. The task is to find the heat flux flowing through the wall and the outside wall temperature. Convection coefficients and thermal conductivities are given. This problem is very simple, and the solution is published in the book. It's a Rajput book. We selected for the demonstration of QuickField general workflow. Now let's run the QuickField and create a new problem. That's a QuickField, and I'm creating a new problem. Let's call it heat transfer. Let's see heat transfer. I press the button finish. Now I should create a geometry. Actually, I'm drawing the wall, and the shape of the wall remains the same at the wall height of the wall, so that we may draw just a little piece of the wall, 1 by 1 meter, and the width is 12 millimeters. That's a wall of 1 meter high. Like this. And I duplicate this edge by displacement on 12 millimeters. And I should link this vertices. And on the bottom, and the wall is ready, but it's not a wall, but it's just a block. Let's name it. Let's call it the wall, and we should set the properties of this wall. Just a state problem, and we should set just thermal conductivity. It's enough. Okay. Also, I should set the boundary conditions on the edges. On the left edge, I'm gonna have the water. It means that this surface is hotter. And on the right, I'm gonna have the air side. And now I set my properties: convection for the water and for the air. That's convection coefficient for the water side with a temperature of this water in Kelvins, 95 degrees Celsius. And for the air, convection coefficient is 10, and the temperature in Kelvins is 15 degrees Celsius. Okay. Now I should automatically generate the mesh and solve the problem. And solution is ready. First, let's look how the heat flux flows through the wall. I press Field Picture Properties and display the vectors of the heat flux. As you can see, they goes from the left side of the wall to the right, from heat area to the cooler area. And according to the conditions, we should calculate surface temperature on the air side. Let's calculate it. It's average surface temperature. And also we should calculate heat flux. And let's compare our results with the analytical one. That's Fury and that's QuickField. Also, we can change our problem. I mean, the conditions of this problem. For example, I can divide my wall on two parts, like this. I can take this edge and duplicate it. And I should, of course, take this vertex to the a little bit to this edge. I divide my wall to set different materials on the left side and on the right side. That's a little mistake here. Let's just place this vertex here on the bottom. Okay, that's very good. Okay, and then I select this. Now it's external parts of the wall, and I will call it insulation, because this part will be insulated, and this part remains the wall with the same properties as in the previous settings. And for the insulation, I set a very low thermal conductivity, for example 0.5 watts per Kelvin meters, and press OK. Now we should generate the mesh again. On each block, of course. That's pretty strange, but it's good for us. The solution is ready. As you can see, the solution changes radically. Now, the temperature distribution is not uniform at all, like in the previous settings. And I can show you the plot of the temperature distribution, and that's a very rapid drop of the temperature in the insulation block. And also I can calculate heat flux passing through the wall. That's my volume, and as you can see, it's reduced very much. Okay, so